The next 6 videos are all about writing chemical reactions. This first video is just kind of an intro on what writing a chemical reaction will entail and what tools you might need to give you a good, strong foundation. The next 5 videos that follow it will be me walking you through how to write and predict the products for a synthesis reaction, decomposition reactions, single replacement reactions, double replacement reactions, and combustion reactions. These are the 5 types of reactions that a first-year chemistry student should be able to identify, and now we'll also be able to predict the products for. And then we will be balancing our equations that we have written. The reason why we are doing this is because if we are able to write chemical reactions, we will have the ability next semester to kind of more dive deeply into maybe figuring out some mathematical relationships between products and reactants within a chemical reaction. Okay, so I'm super excited about this. This first video, like I said, is just kind of setting the tone for what we need to be doing. For all videos going forward, you will definitely need a periodic table. You guys, I do not know how we would get through a chemistry class without our periodic table, but for sure with writing these chemical reactions, specifically on the back of our periodic table on our reference charts, we have a chart for solubility rules, which we'll be using when we have a lesson on double replacement reactions. And we have the activity series, which we'll be using when we talk more in depth about how to write reactions for single replacement reactions. Super important. Now, since we're like writing reactions and maybe writing formulas for things, maybe needing to write some compounds, covalent compounds, ionic compounds, it may also be useful for you guys to bust out your colored periodic table where we colored our metals red and our nonmetals blue, showing the difference between a cation, ones that lose electrons and become positive, and my anion nonmetals, the ones that gain electrons and become negative. We will definitely be needing those oxidation numbers to figure out from a crisscross what ratio of each one of these ions I would need to each other if I'm forming an ionic compound on my product side. We will probably want to involve our red and blue colored pencil, so when we are writing our chemical reactions, we can kind of identify and get a placeholder on seeing our couples, our compounds, and seeing what happens when we shuffle them around to make new couples potentially. Okay, so like I said, this is just a kind of intro video to kind of set the tone, get us kind of started to where we need to be. So this is what it's like to write chemical reactions. Super exciting. It's all about these 5 types, right? We know our synthesis reaction, you see 2 single people and they make a couple. Our decomposition reaction is a breakup. I see a couple and they break up into 2 singles. A single replacement reaction is a kind of cheating situation where I have one single person and a couple. That single person comes in and displaces or replaces somebody from the couple, and you have a new single person who has been kicked out. A double replacement reaction is where I swap partners, right? I start with 2 couples and I find 2 new and different couples. And then my combustion reaction is where I take a hydrocarbon, anything that has a certain amount of carbons and hydrogens in it, and I burn it in the presence of oxygen to always produce carbon dioxide and water. And the result of these combustion reactions is that's where I get a lot of fire and heat and all of that fun stuff. Okay. So with this lesson on writing our own chemical equations, I will always provide you, these are the reactants. You will need to know, based on those reactants, what to do, what products they're going to make. And you're like, well, how do I know which one of the 5 types? You just have to look on the reactant side and see what you got. If I wanted to, I could cover up everything on this right side of the screen past the arrows. And if you see 2 single people, the only option for you to do is to make a couple or a synthesis reaction. If you see just one reactant as a couple, the only thing you can do with a couple is to break it up. You've got a decomposition reaction. If you have a single person and a couple, that's going to set you up for a single replacement reaction. If you got 2 couples, that's your double replacement reaction. And then if you see specifically a hydrocarbon and an oxygen, you know you're going to combust that thing and write CO2 and water as your products. Okay, so it is all just looking at what players I have given for you as reactants to kind of predict what type of reaction they're going to be in. Okay, so we know our 5 types. We are super excited. We will be able to predict the products for reactions and write our own reaction equations. And Chemistry Cat says, once I told a chemistry joke and there was no reaction. Maybe some of our reaction types have the possibility of having a no reaction. We will have to see. Okay, so we got some steps. We got some steps for writing chemical reactions. This is an intro video. I will go through these steps as to what is applicable for each one of my 5 reaction types in those separate reaction type videos. But this is just a general frame of mind that I got to get things right for, okay? Determine what type of reaction you have. We mentioned this before. What you got on the reactant side? 2 singles, synthesis. I got a couple, break them up, decomposition. If I got a single person and a couple, oh man, that's some cheating. We got single replacement. 2 couples, we're going to swap some partners. We got double replacement. And then my hydrocarbon and oxygen, I know I will be combusting. Amazing. Okay, so after I figured out what category I am in, I am ready to go. I will then write some formulas. I will write the formulas for each reactant and each product. Well, how am I going to write a formula? You're going to use your nomenclature rules, okay? Now, when we talked about the types of reactions, I'm using these terms like single, people, and couples. Well, my couples are my compounds. Whether those compounds are between a metal cation and a non-metal anion, that's an ionic compound, right? Or a polyatomic ion. We know we have our list of polyatomic ions which act like metals or non-metals depending on what their charge is. The key thing about if I am making an ionic compound, that metal, that red metal always gets written first, right? And I crisscross their oxidation charges to figure out the subscripts or the ratio of each ion I need to each other in order for them to neutralize their overall charge. Okay. I also have the potential of making a compound a covalent compound between two nonmetals. We know I'm not using crisscross. We know that I am just using prefixes to tell you how many of each one of those elements you have. These are how I write formulas for compounds, which are my couples now in my relationship drama, right? I can also write a formula for a single element. This is super easy. Find that element symbol for the periodic table and set it down on there. Unless you are a diatomic element. My diatomic elements, I say Hofbrinkel. See, so hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. If I want a single of them, they always come in twos. They always come in twos, so you will have to put a subscript 2 underneath them. Any other element besides these Hofbrinkels, you just write one of them, okay? No subscripts, just the symbol. There's a real kind of cute way to remember my Hofbrinkels. There are actually 7 of them, the hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine. So what's real fun is that my Hofbrinkels, well, here's hydrogen. He's up there by himself, which is super weird. But the other 6 actually make a 7 over here. So I can grab nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Those guys. Isn't that super fun for us? So we get the 7 diatomic elements from these guys right here, and then my hydrogen over here. So I thought I would just point that out because that is kind of useful for us. Okay, so I can write formulas. Look at us for single elements or for compounds. We are now putting everything all together. Okay, now once I've gotten all the players, I've gotten all the reactants, I've gotten all the products, I'm going to balance. We know when we balance, we do not change subscripts. Oh, no. We only add the big numbers in the front, the coefficients to balance. We just practiced that last video. We mentioned some balancing tips. If I've got a polyatomic ion intact or all together on each side, I'm going to balance that thing all together, not worry about breaking up the individual atoms within the polyatomic to figure out their individual totals. We mentioned that water, H2O, it's sometimes helpful to write as HOH, especially if I see the hydroxide polyatomic ion, or OH, on the opposite side of the water. I may be using water as a couple or a contender in a single replacement or a double replacement reaction in that case. Amazing. Okay, specifically if I am dealing with single replacement reactions, we have a chart on the back of our periodic table that is called the activity series. This activity series is like the who's hot and who's not of the periodic table. I have a list of the hot and not metals on the periodic table. The higher I am up on the activity series, the more attractive I am, or more active, but also attractive. And the lower down on my activity series, the less attractive or the less active. We know that when it comes to making couples, right, the more attractive person is always going to be preferred in the couple. Okay, I also have a who's hot and who's not list of my non-metals. Non-metals can also undergo single replacement reactions, but I'm not going to talk too much about this until we get to the single replacement reaction video, but I will be using this activity series for those. Finally, I've got another cool thing. I've got a list of these solubility rules. These solubility rules are used for double replacement reactions to determine if I'm forming a solid precipitate. We will practice identifying where I am or what you are looking for on this solubility rules chart. But if I fall down into the bottom insoluble category, that will be an ionic compound that will be a solid precipitate. Okay. So that was a quick little introduction on what we're about to dive into. Yeah, we're going crisscross if we need to crisscross, right? We're going to be really blasting hard our diatomics and understanding what it means when I'm swapping partners and stuff. So I'm excited to start predicting products of some chemical reactions with you guys.